Every year, humanity produces over 400 million tons of plastic, and almost half of that never gets recycled. Instead, it ends up choking our oceans, burying our landscapes, and entering our food chain. Plastic pollution isn't just an eyesore, it's a ticking time bomb threatening ecosystems, wildlife, and even our health. But what if nature has begun fighting back? In recent years, scientists have discovered something extraordinary: bacteria that eat plastic. Yes, you heard that right. Microbes capable of breaking down one of the most persistent pollutants on Earth. Plastics are synthetic polymers, materials made of long chains of molecules. They are durable, lightweight, and incredibly versatile. That's why they are used in everything, from packaging and electronics to clothing and cars, but their durability is also their curse. A single plastic bottle can take over 450 years to decompose. Meanwhile, more than 8 million tons of plastic enter the oceans every year, and by 2050, it's estimated there will be more plastic than fish in the sea. Even worse, plastics don't just disappear, they break down into microplastics. Tiny fragments that contaminate soil, water, and air. Scientists have found microplastics in human blood, lungs, and even in the placenta. The world desperately needs a solution, and surprisingly, it may have come from a most unexpected place: a garbage dump in Japan. In 2016, a team of Japanese researchers led by Dr. Kohei Oda was studying a strain of bacteria found in a plastic bottle recycling facility in Osaka. While examining piles of polyethylene terephthalate, better known as PET, they discovered something incredible: a microbe that was not just living among plastic but actually feeding on it. They named the new bacterium Idoenella sacchariniensis 201F6. This microbe had developed the ability to produce two key enzymes, PETase and METase. Together, these enzymes break down PET into its basic building blocks, terephthalic acid and ethylene glycol. These byproducts can then be reused to make new plastic, creating a potential circular recycling process. This discovery made headlines around the world. For the first time, scientists had found a living organism that could digest synthetic plastic. It was nature evolving in real time, adapting to humanity's pollution. But the bacteria weren't fast. In nature, Idoenella sacchariniensis could take weeks to break down a single piece of plastic. To make this viable for large-scale recycling, scientists needed to speed things up. In 2018, researchers at the University of Portsmouth led by Professor John McGeehan engineered a mutant version of the PETase enzyme that was 20% more efficient. By accident, they made it better and faster. Then in 2020, researchers combined the two enzymes, PETase and METase, into a single super enzyme capable of breaking plastic down even quicker. These breakthroughs marked the beginning of bioengineering a real-world plastic solution. More recently, in 2023, a study published in the journal Frontiers in Microbiology revealed that over 30,000 plastic-degrading enzymes have been identified in bacteria and fungi around the globe, from ocean floors to Arctic soil. Incredibly, the microbes seem to be evolving in response to plastic pollution. This wasn't just a one-off phenomenon. Across the world, bacteria were developing the ability to consume plastic. What was once a synthetic material too tough for nature is now slowly being integrated into the microbial food chain. So, what does this all mean? Can plastic-eating bacteria really save us from environmental collapse? In theory, yes. These microbes could be harnessed in bioreactors to create enzymatic recycling plants that are far more sustainable than current plastic recycling methods. Unlike traditional recycling, which degrades plastic quality, enzymatic processes can restore it to virgin-grade plastic, reducing the need for new fossil fuel extraction. We are also seeing potential for using these enzymes in landfill remediation. Imagine spraying plastic-eating enzymes on old dump sites, accelerating decomposition and recovering materials for reuse. But the implications go even further. Plastic-eating bacteria could revolutionize how we think about materials. Scientists are already working on bio-based plastics, designed to be consumed by engineered microbes after use. This means a future where packaging biodegrades in days, not centuries. But like every scientific breakthrough, there are challenges. Firstly, scaling up microbial digestion isn't easy. Enzymes require specific temperatures, pH levels, and conditions to work efficiently. Engineering industrial-scale reactors that can handle massive quantities of plastic remains a work in progress. Second, not all plastics are created equal. PET is just one type. Polyethylene, polypropylene, PVC, each has different chemical structures. We will need different enzymes or enzyme cocktails to tackle these. And finally, there's a risk. Releasing genetically engineered bacteria into the environment could have unintended consequences. It must be tightly controlled. Despite the hurdles, this microbial revolution gives us hope. We are witnessing an evolutionary counterattack. Nature adapting to humanity's excesses. This discovery reminds us of a vital lesson. We are not separate from nature. Our inventions impact the planet, but nature always finds a way to respond. Sometimes that response could be the very thing that saves us. And who knows, maybe one day our future will thank bacteria for saving the world. If you found this story fascinating, hit the like button, subscribe, and share this video.